That's the problem here, is that it is very, very low. That means we have more of this HA, right? Another way to look at this is just the process of ionization, right? If this were big, then K would be a big number. It's not. If this were big, the pH would be equal to the negative log of the H plus, but it's not, right?
So
If
how do we know that it's not?
these two are equal, right?
Hmm.
So if we put that as x, that will be x squared. Unfortunately, this will be very small, right? So then we have HA equals K. And this will be very large. We multiply that by the K. We take the square root of the whole thing, and the concentration of these is equal to the square root of the concentration times whatever the K is. In this case, we actually call this the K of the acid, the Ka. Remember Ha-Ka back in the day?
Yeah.
A little bit, right? So this is a very small number. So when we multiply it by the concentration of the acid, we're going to get a very small concentration of X, right? So what does this all mean? In layman's terms, it means that this does not easily become this. That means it's a weak acid. If something gives you a Ka for an acid or a Ka for an acid, then that means that you're dealing with a weak acid. Weak acid tells you that there's weak ionization. The only thing that makes an acid is it's a proton donor, right? I mean, there's many different rules for an acid, but that's the major one, a proton donor, right?
Yeah.
That's what that's doing. And if it's not a proton donor, if it's not a very good proton donor, it is weak. So the only thing that they would want you to say for that is just like it's written in there, it doesn't ionize 100%. It ionizes probably 5% ethanoic. Ethanoic is the same as acetic acid, actually. C2H3O2H, yeah.
Yeah. Vinegar.
Vinegar, yep. So ethanoic acid is a weak acid because it does not, you could say it does not ionize appreciably, or it does not ionize. To tell you the truth, that's probably a strong acid ionizes 100%. HCl ionizes 100%. H2SO4 ionizes 100%. HNO3 ionizes 100%, right? HClO4, perchloric acid, ionizes 100%. Hydrobromic acid ionizes 100%. Those are the 6 strong acids. They ionize 100%. Everything else does not ionize 100%. So they are considered weak acids.
All right.
I'm forgetting one. Is hydroiodic acid strong? I think HI is also. sulfate, chlorate, perchlorate, nitrate. So there are the 8s of everything except for phos, obviously. And then the 3 halogens except for fluorine. Fluorine is so electronegative, right?
Yeah, so the more like essentially the closer the bond is through like electronegativity, the more likely it's to be a weak acid because it doesn't want to give away the proton.
To tell you the truth, that makes sense, but that may not be 100% true. But in my mind, you know, that's why. But you would never need to see this why. Yeah, you would just need to memorize it. We can look it up. That's what I would say.
I mean, I'm just like, yeah, just out of like
trying to get an
like,
understanding.
what I'm thinking and understanding. Yeah.
Hydronium ion is attached to the fluoride ion and it isn't free to function as an acid, limiting the strength. Hydrogen bonding also accounts for the higher boiling point. Dun, dun, dun. Here we go. This is kind of funny. So this does it all. Hydrofluoric acid is the only non-hydrohalic acid that is not strong. So right there we have HCl, HI, and HBr. R, HF not.
Good afternoon, North Central. This is Ms. Watkins.
There we go. Hydronium ion, H3O, and F negative are so strongly attracted to each other that they basically form this bond pair because the hydronium ion is so positive and the fluorine is so negative. So it doesn't actually just allow that H to be taken off of the H3O plus. So, yeah, quite weird. But again, I wouldn't worry about that. Just memorize these guys. Last thing, before I let you go, I want to make sure I get this out if you have to make a beeline for it or something. I added some HNMR questions. This is kind of cool. By next Tuesday, if you want to meet, like, I don't think we're meeting on Thursday because of early release and all this other stuff.
Oh, really? Early release? What are, okay. School.
Yeah, right. Why are we doing that project when everything is going on? But so we won't meet because I need to prepare for whatever the heck I'm doing that day. Sorry about that. So you would want to take a look at these HNMR questions. And this is kind of cool. I think that this is going to give you a pretty good test. It asks you to describe like the different environments. Remember that that's how many spikes it would have or how many different kinds of hydrogens there are. And the peaks. And you can go from as deep and detailed to these as you want. We'll take a look. And then it actually has one where they give you the reading. And they want you to determine the empirical, molecular, and then draw possible structures of it. And then determine if you can figure out what it is. So by now, next Tuesday, if you can, and I mean, remember, I'm just doing this as just a discussion. I'm not trying to grade this or anything else. I just want to see where you are on it, right?
Like, I also want to see how I am on it.
Yeah, right. Any other questions about the, did we get that HF, the ethanoic acid thing? Did you need more than that?
No, that explains it pretty well to me.
B?
I mean, like I understand kind of like big picture. It's going to somehow shift it over to the product or over to the reactant side and produce fluorine gas, but I don't know how it's going to do that. I don't understand how it's going to do that.
So if we add an acid, here, let's write this equation out. CCl2 plus 2NaOH yields.
You're writing something down. I don't see it.
I am a dumb. How's that?
Uh,
You're writing something down. I don't see it because you know why. You're stupid. You did not set it up. This is
no, you're
All right.
plenty smart. I'm sure of it.
You're just not very good. No, I'm just kidding. Computers. If we take a look here, we need to make basically tells you that why is it dangerous to mix vinegar and bleach? So a solution of bleach is made. You know that sodium chloride is not bleach, and you know that water is not bleach. So that tells you that sodium, this oxygen chloride, this is sodium hypochlorite. Sodium hypochlorite is bleach, right? Yes?
Yeah. Yes.
We're not used to seeing hypochlorite like that. Usually it's ClO in our minds. Okay.
Maybe
Oh.
trying to trip us up.
Yeah. Knuckle. Looks cool though. So we know that this is bleach. I'm sure that even if you did not know that, sodium hypochlorite, you would be able to figure that out from the words in the question. Suggest with reference to Le Chatelier's principle why it is dangerous to mix vinegar and bleach together. So we know that bleach doesn't ionize 100%. I'm sorry, we know that vinegar does not ionize 100%, but it does give off this H+, right? And the more H pluses that are given off, that H plus is going to react with, if we were to do, and this is always fine, if we were to do, like the just the ionic equation, we would see Na plus OH. Those H pluses are going to combine with the OH. So the hydrogen ions donated by the vinegar are going to react with the sodium hydroxide. And that's going to cause a decrease in reactants, which will speed up or shift. I'm going to put speed up. I'm not going to put speed up. What do I want to do?
What do you want to do?
Decrease in reactants. Which will favor the reverse reaction. There's so many stupid things you can say. You can say favor the reverse reaction, shift left. All of these things are the same thing. That's why.
It's just because it's the ethanoic or the vinegar that's reacting with the sodium hydroxide, which is what makes it favor the other side.
Yeah. So basically, a reduction in reactants or a lower concentration in reactants is going to cause the system to shift left or favor the reverse reaction, producing chlorine gas.
All right. Makes sense.
That's awesome. And I mean, yeah, I mean, you had that 2 years ago with Le Chatelier's principle. We're getting ready to go at that over that by the end of this week, right? It'll
I
reinforce.
mean, like I said, I kind of understood that it would like favor the reactants at some point, but I didn't quite understand how it would achieve that, so to speak.
Yeah. And it is one of those things. Basically, they're using something that reacts with one of the reactants, right? Something that cools that
Yeah.
out. What kind of reaction is that? Well, through a help me out, neutralization reaction. Reacts with the hydroxide. Vinegar will react with the hydroxide in the neutralization reaction, causing a reduction in reactant concentration, which will then favor the reverse reaction, producing more chlorine.
It's quite a few steps. Well, and yeah, not necessarily going to go over the last question because that isn't really something to go over, considering we're going to learn about it.
Yeah, Yeah.
in a bit.
No worries. Yep. Cool.
Cool.
All right. Have a great day, man.
You do the same.
Get some sleep. Get that alarm going.
I will.
Take care of yourself. Bye.